In section 3.3 we learned about the addition rule. Basically we came up with a formula P of A or B. Instead of and we have or now, which is addition. But when events are not mutually exclusive, we also had to subtract a piece, A and B. And just to help you remember, we used a Venn diagram to show this. We have one circle, and then we have another circle, and they overlap, saying that they're not mutually exclusive, that they can happen at the same time. They can. We have A and B, then this shaded area right here, we call this A and B. So basically, let's look at this another way, because this video is about calculating a formula, well, deriving a formula. So basically something like this, but for the probability of A or B or a third event C. So that is what we're going to be working on here. So if I just erase that part, if I count the probability of A on the right hand side of the equation, that's equivalent to counting the area inside of here and also the area in here, because both of these are basically, we're splitting up A into two pieces. So when you count the probability of A, you make sure that you just put a tally mark in every single area of circle A that's in circle A. So for B we do the same thing. If we add B, we're going to put a tally mark in every single area of B. So with this section, when we're adding, we make sure that we don't add duplicates. When we have two things here, that means that we have counted this area twice. So therefore what we will have to do is subtract or just take away one of these from this Venn diagram. Let's take a look at a Venn diagram drawing of three circles, and then we'll derive this formula for three from them. So let's draw a normal Venn diagram. Okay, let's call this A, B, and C. So if we count the probability of A, we just put a tally mark in every single one of these areas that are in circle A. So we have probability of A. We added that. So now B, we put a tally mark in here, 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 and here. All three of these areas are in circle B. Plus, we go to C. Let me complete that circle there. We go to C, we put a tally mark in here, 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 and here. So now we have a tally mark for everything in C. So now what we want to do is what we did with the first Venn diagram example. We want to make sure that these areas right here don't have more than one tally mark. See, this area right here, this one has two tally marks, and this area has three, for example. We want to make all of them have one, so all we have to do is subtract some things in order to make them all one. So the way we do this to represent them in math symbols is just like we did for section 3.3, when we said probability of A and B, we subtract that. Let's see what happens when we subtract probability of A and B. That is, let's subtract 1 from every single area. Let's erase a tally mark from every single divided area inside of this intersection between A and B. So let's do that. If I subtract 1 from here and I subtract 1 from there, then I have only one tally mark left right there. So if I subtract A and B, I need to write it down. Everything I do, I need to write down A and B. So we got that out of the way. So now let's subtract A and C. Let's say minus the probability of A and C. If we do that, we have a similar result. When we subtract A and C, we get the same type of result that we did when we subtracted A and B. We just delete that tally mark and that one. So now let's go ahead and subtract B and C minus the probability of B and C. When we subtract the probability of B and C, we just subtract 1 from here, or just erase it, and erase that last one in there. Now, all of the areas in this Venn diagram are 1 except for this area right here, where there's nothing at all there. So what we have to do, since it's nothing, we're going to have to do something to it to make it a 1. If you have nothing, or in other words 0, what do you have to do to 0 to get 1? You add 1 to it, right? So if we add 1, we put a 1 there, then we'll have a 1 in all of these areas. And so this may not be obvious. That one right there, that was a 1, okay? So they all have 1. So we add 1 to it. We added 1 tally mark, but 1 what though? We still have to represent this in math symbols. This right here represents A, B, and C. It's where circles A, B, and C intersect. So we added 1 of those areas back to the total. So we have 1 times the probability of A and B, not or, and. These are all and, right? It's where they intersect. It's where it's both one and the other. And in this case, it's all 3. This and this and this. Therefore, we can just get rid of that 1 to have this formula.